Okay, guys, today actually we're going to start in section 4 and the last section in our curriculum or our material for that quarter and this academic year. So we're going to keep talking about the organic compounds, but today we're going to start in section 4 talking about what are the reactions that different chemical compounds are able to do. So actually, as we have different types of chemical compounds and we classify them into different categories regarding to what kind of functional group included in the organic compound. So each category is able to do certain types of chemical reaction. Also, the chemical reactions of organic compounds are classified into certain patterns of reaction. So what are the reactions that different chemical compounds are able to do? Let's start by the first kind of reaction, which is substitution reaction. So from its name, it's easy to predict what will happen in that kind of reaction because we said it's substitution. So it means there is an atom is going to replace or switch place with another atom. So it's substitution. One replaces another one. So as we know that here in any organic compound, the carbon atoms already is able to form 4 hydrogen bonds, and these hydrogen bonds simply they could be filled by hydrogen atoms, usually maybe another types of atom. So in substitution reaction, we're caring about the hydrogen atom because this hydrogen atom could be replaced by another atom. So in that case, we call it substitution reaction. For example, here, as you can see, that is methane. So methane represents the simplest hydrocarbon or saturated hydrocarbon, just one carbon completely filled by 4 bonds with hydrogen atoms. So once it reacts with chlorine gas, Cl2, so we could find that this hydrogen easily to be replaced by this carbon. So the hydrogen will be removed and bond with this chlorine, while this chlorine is going to replace the hydrogen, and that's formed the chloromethane. So that is a substitution reaction. So whatever you could imagine that any other element like halogens, chlorine, fluorine, bromine, iodine, they could replace the hydrogen. And also some metals, sometimes they could replace, that hydrogen, So, but usually here we find that the halogens, they could replace the hydrogen. In that case, they form the alkali halide, We see that alkali halide just R, which means a methane that lack, or which means, sorry, alkane that lack for a bond, and this bond is replaced by chlorine. And actually, this considered as an initiation reaction for many other reactions. That mean I cause this halide alkyl, which is produced in different purposes and different reactions, as we studied in the previous section. So here we could find like that in this step, we just replaced one hydrogen only by one chlorine. So what about the rest 3 hydrogens? Are we able to substitute them or replace them? Actually, yes. If we repeat this reaction one more time, so that means if we get the chloromethane and we start to react it with extra chlorine, so actually another hydrogen will be replaced by chlorine, and then the third and the fourth. That means I could make this reaction 4 times, or using amount of chlorine that enough to substitute the 4 hydrogen. And in that case, I get that chloromethane. So the tetrachloromethane, that which is known as CFC, or the compounds which are used in aerosols and ACs and so on, like the freon, or which is known as freon, as a common usage. That which we explained last time. So like here, that the substitution reaction. So for example, here, if we get the monochloromethane, this one, or the sorry, that's here the tetrachloromethane, this one, and we start to react it with, the hydrogen fluoride. So we could find what happened in that case. Actually, the fluorine able to replace the chlorine. So it's also a substitution reaction. So why fluorine is able to be or able to replace the chlorine? Because fluorine is more active than fluorine. Fluorine, sorry, is more active than chlorine because it's above it in the group of the are halogens, and as we know, the metals, as we move up, the reactivity increases. So fluorine is the most reactive non-metal, so it easily replaces the chlorine, which is less reactive. While the opposite reaction cannot happen. For example, if I have, look at me carefully here, if I get, for example, this halide alkyl, CH3, like this, and just good, that's here Cl, and I'm gonna just react it, for example, with Br2. So this is Br connected to Br, 2 molecules of bromine. So this bromine is able to make a substitution reaction with this halide alkyl, yes. But does it will replace one of the hydrogen or replace the chlorine? What do you think, guys? Once I get the monochloromethane and react it with bromine, so this bromine is make a substitution reaction, but what do you think? It will substitute the hydrogen or the chlorine? What do you think? Just guess. So actually, the bromine here will replace the hydrogen because bromine is less reactive than chlorine, so it will not be able to replace the chlorine. So in that case, one of these Br will just replace the hydrogen, and the hydrogen, okay, will combine with the other Br and forming HBr. So in that case here, it will be, okay, chloropromomethane, okay. So like this, it's another substitution. But for example, if I have tetrachloromethane, for example, like here, so in that case, I make it react with bromine. Okay. So this reaction will happen. Actually, this reaction will not happen. Why? Because we could find that chlorine is more reactive than bromine. So bromine is not able to replace any one of these chlorine atoms. So this reaction will not work. So like this here, okay, but if we use the fluorine, for example, this reaction will run because the fluorine is able to replace chlorine because chlorine is more reactive than fluorine. So here like this, we said that it's a substitution reaction. So in substitution reaction, simply the more reactive atom could replace the less reactive one. So one atom will replace the another. Usually, okay, hydrogen atoms which are found in different organic compounds easily be substituted by halogens to form halide alkyls, okay, especially in alkanes. So here like this, okay, that the first type of chemical reaction, which is that's a substitution reaction. But we pass to the other hand, the other type of reaction, which is the addition reaction. So once we talk about addition, that means something will be added to the chemical compound. No substitution here. That means we will not remove anything from the compound, but we are going to add something to the compound. So like this, if already in saturated hydrocarbons, that means in alkanes, once the carbon is completely filled or it has the four bonds with other atoms, is there any chance to add anything? Actually not, because already each carbon in alkanes have four bonds, so it's completely saturated and it has no chance, or it doesn't have any empty atom to, or empty, sorry, bond to be able to add new elements. So that means this kind of reaction will already or would be suitable for unsaturated hydrocarbons or unsaturated bonds. That means the chemical compounds that contain double covalent bonds or triple covalent bonds, because in that situation the compound is unsaturated. So once we break down these bonds and add elements, we're going to convert it into saturated. Okay, so let's get an example here. Okay, for example, if you look at this compound, okay, before this, let's get a simpler example. So if we get a simple example here, the simplest alkene ever is ethene, just two carbons, okay? These carbons has a double covalent bond between them, and here that's four hydrogen, as we can see here. So what would happen, okay, if I make this compound react with hydrogen? So in that case, we're gonna find this double bond is a weak bond, so it easily be broken. And once it's broken, that means this carbon now like for a bond, and this carbon also like for a bond. So each one will get one of these two hydrogen. And in that case, we changed the ethene into ethane, changing from alkene to alkane. Why? Because here, okay, we already break the bond, and now all the bonds between the carbon atoms become saturated or a single bond. So we convert it from unsaturated hydrocarbon to saturated hydrocarbon. The same could happen by using another elements, okay, or another, for example, a halogen in a state of hydrogen. For example, if I made this react with Cl2, so what would happen? Also, we're gonna break this bond, and then after this bond is broken, this will get one chlorine, and this one will get another chlorine. So in that case, here we have dichloral ethane. Okay, so also in that case we converted from unsaturated to saturated, and as you could observe here, we didn't remove anything from the original compound, but we added atoms to the original compound. So that's why we call it addition reactions. Also here we could find, for example, guys, I'm gonna just tell you here, if you have this ethene, okay, C2H4, how could I get CH? How could I get this compound? Okay, so CH3, CH2Cl, how could I get that from this? So what the kind of substance that I could make it react with this one? What do you think? Who can answer this? 2 marks bonus. guys, how could I convert these into these, okay? Or how could I get the monochloroethane from ethene? So how could I make it this? Anyone have an idea?
We will break the double bond between
Yeah.
the two carbon.
Yes, how we are gonna pick what substance that we're gonna make it react with?
Cl.
Just Cl2, because chlorine always is dicovalent. So
Yes.
in that case, I'm gonna have one Cl here and one Cl here, but I just has one Cl and here hydrogen.
Uh,
Good trial, Hassan. Think you are gonna reach it.
هي there is hydrogen under the
Yes,
first one.
yes. Any empty dash, it means hydrogen. We agreed about this from about 3 sessions ago or 4 sessions. Okay,
Yeah.
so like this, they are hydrogens already. Any empty
Uh,
dash means hydrogen. So actually, if I make it chlorine like this, okay, it will not work because this two chlorine, I will add here
mm.
chlorine and chlorine, so they will be Cl and Cl, but here Cl and that's H. So
It
what
will
should?
be HCl.
Yes, good. I could make it react with HCl. Okay, so this one here wants to react with hydrogen chloride. So I'm gonna break the bond. One hydrogen will be on one atom, and the other atom will carry the chlorine. So that's a good trial. Or you
Yes.
can make it on two steps as we used. First of all, okay, here let's show the other alternative. If I just reacted with hydrogen, so in that case, what would happen? What it will gonna produce, Hassan? It will break the bond and each carbon will get hydrogen, so it will be CH3, CH3, yes or no?
Yes.
Yes, then react this one, okay, with chlorine atom, Cl2. So in that situation, because it's now become saturated hydrocarbon, that means all single bond, it will be a substitution reaction, not addition. So we will replace one hydrogen only with one chlorine. So it will be CH3, CH2, Cl, okay, and the other H will combine with the other chlorine and CH. You get the idea? So whatever you can make it on one step
Yes.
as addition reaction, or you can make it as in two steps by saturation reaction, and then you're gonna make a substitution reaction. Is it hard like this? Any hard question? Any hard question, guys, until now? Clear, Hassan?
Yes, miss.
Okay, so like this, we know that is the addition reaction. Actually, addition reaction is one of the most common reactions in a lot of industries that we are finding every day. For example, as we know that the oils, most of oils, they are unsaturated. That means they contain a lot of double or triple bonds, okay, between their carbons. So we make a kind of addition reaction which we call the hydrogenation reaction. That means adding hydrogen, okay. So the idea of hydrogenation reaction that we start to add hydrogen atoms to this unsaturated hydrocarbon chain. Okay, so what would happen? The bonds will break down and we are gonna add hydrogen. So once that's happened here, the oil slightly, its mass will increase and it will turn from a liquid state into solid state. That means it will turn from oil to fats. That's how we make the kind of pearl that is used from the plant's oil. Okay, so actually we call these the unsaturated fats, or we call it hydrogenated fats. Many times when you bring a kind of pearl to your home, you may read on its label hydrogenated fats. What I mean by hydrogenated fat? That means it's not a naturally fat that formed, because naturally fats obtained from animal source, okay, like me from milk. But the hydrogenated fats, okay, that means the already fats made from oils which already are obtained from plant source. Then we use these oils and start to hydrogenate it, add hydrogen to it, so we convert it into fats. Actually, this kind of hydrogenated fats is not healthy. Okay, so that's what means we're supposed not to consume it too much, because it's actually related to the heart diseases and the atherosclerosis and a lot of problems, okay, in the circulatory system. So that's it's not better to use it or to intake it in large amounts. Okay, the same idea, this kind of hydrogenation or addition reaction is used in many reactions, okay, for a lot of industries and something like this. So like this, guys, we studied two types of chemical reactions that could done by an organic compound. First is a substitution reaction. Second, which is the addition reaction. Any hard question here, guys? Guys, any hard question?
No, sir.
Oh,
Okay, so like this, okay, we just stop at this point. Okay, please study these two types very well. Okay, from your textbook, and if you have any question, you can send to me anytime. Thank you, guys, and goodbye.